Hey y'all. This may be a bit of a shorter video this time around, but let's jump into surface area. I think I'll answer most of the questions while we're in class. Looking at the surface area of a rectangular prism, or a prism or rectangular prism is basically what happens when you take a rectangle and you stretch it into the third dimension. So, while a rectangle's area is length times width, the volume, well, I guess we'll jump into volume in the next video, but it's going to have six faces whenever you stretch it out. Kind of like how a cube has six sides, like, dice. We've seen plenty of those lately. Um, you can treat each face like a rectangle, and that's what we're going to have. So right here, if we actually look closely, we've got a width that is constant at 2, a depth, which is that third dimensional measurement, which is constant at 5, and a height constant at also 2. So we're going to have 3 rectangles that are repeated twice in order to find this area. One that's the green square on the front that is too wide and too tall. So we're going to have that one. We're going to have the red one that is 5 wide, or I guess 5, yeah, wide, and too tall. And we're also going to have the blue one that is 5 deep and too wide. Those are going to be the length times width of each of our rectangles we're working with for this prism. Now we're going to have to double this because the rectangle has a top and a bottom, a front and a back, and a left and a right. And we've only gone ahead and calculated one of each of those, so when we double this, we're going to get the actual total. I'll throw that into a calculator, and our answer that we're going to get is 48. So we're going to say 48 is our surface area. Perfect. That's all we're going to have to do, just changing the parameters here. For each pair of numbers, there's going to be a rectangle corresponding. So this has a 2 and a 5. It has a 2, a 5, and a 4. So we're going to have a 2 times 5. We're going to have a 2 times 4. And we're going to have a 5 times 4. Make 76 when you double it. Notice that we can use the same expression each time because we're going to have 2 of each rectangle. I'll explain a little bit more detail in class, but we're going to have 2 of each because top and bottom, left and right, front and back. And then each combination of like length, width, and height is going to make its own rectangle. So basically, we're going to have a 2 by 4, which is green, a 4 by 5, which is red, and a 2 by 5, which is blue. In the last problem, we had 2 that were 2 by 5s, just because we had a square base, which means 2 of our measurements actually were 2. This next one, we're just going to change. We got 1, 1, and 6. So we got 1 and 1, 1 and 6, and another 1 and 6. Gives us 26 when we throw it in the calculator. What we have to do, and we're satisfied with that. 2, 8, and 6. So we're going to make it 2 and 6, 2 and 8, and a 6 and 8. Gives us 152, and we're just going to trust that because that's the formula that we're getting used to. Okay, well, this is one we've seen before. So we got a 2 and 4, 2 and 5, 4 and 5. Gives us 76, and we've already done the first part. Let's just go ahead to the next section. So this is going to be a little different. However, we don't need to worry yet about the actual height of the pyramid, but only the slant height. So this is going to be something squared. So 1 squared, because it's going to be the side length of the square of the base. And we're going to have 4 triangles. So we're going to have 4 times something. Now, a triangle's area is 1/2 the base times the height. And our base is 1. Actually, you know what? We're going to just say 4 times 1/2 of, the base is 1, and the height is also 4. So we're going to use that. So it's going to be 9 is our answer. I'm going to try again. There's a lot of 5's in this. So the square base is 5 on each side. So we got a 5 squared. Still going to do the 4 times because we have 4 triangles. 1, 2, 3, 4. And the 1/2 is going to stay put also because that's part of our formula for the area of a triangle. Now we're going to use base. 5 is the base. 5 is also the slant height because it, well, says the slant height is 5. So 75. Hopefully we'll find one with different numbers here. That's the same problem. I'm just going to say 75 again. That's a bunch of 2's. Let me find you one that doesn't have the same number for every single value. 12. Same thing. I'm going to try to find you one that's better. So we're going to have 4 squared because it is going to be the side length of the base. And then you got 4 triangles with base 4 and height 5. Put that answer in. We're already done with the surface area of these of these square pyramids. And then the last thing for today is cylinder. This is going to be the most in-depth, but it's still not going to be too bad. So we're going to have 2 circles and a kind of an outside. The way we're going to find this is to break it into those 3 pieces. Now, if you unfolded the cylinder into a rectangle, I know I've used this example a few times, but consider as if you were looking at a can of soup that had the paper around it. Now, instead of calculating the surface area of that can, as it is a can, what if you just unfolded that paper and found the lateral surface area, meaning the surface area that's not the top or the bottom? Then you would treat all the way around the circle as the width of a rectangle. And you would just treat the height of the can as the height of the rectangle. And you know how to solve that. So what we're going to do is we're going to say pi times r squared, but we're going to have 2 of these because we've got a top and a bottom. So those are going to be the circles. Pi r squared is the area of a circle. We reviewed that last week. So 2 pi r squared, we can actually do it without little multiplication dots, plus, what's that value going to be? 2 pi r is going to be the circumference of our circle, and then times h. That's going to be our height. And now in our case, it's going to be 8 for the height. 3 is going to be the radius. So we're just going to replace our r's with 3's and our h with an 8. So 207.3. Nearest thousandth. I thought it said nearest tenth. We did the math right. I just did my rounding wrong. 3 decimal places for thousandth. Perfect. And just like it says, circumference times the height. So all we need to do, we replace our height with that 5, radius with that 2, and we're going to take that to 3 decimals. 87.964 rounds up to 5. Height of 7 and radius of 4. Replace height with 7, replace radius with 4 where it appears. 276.46. You can say 460 because the next digit's a 1. That's all we got to do. We're just going to these formulas and we're plugging in the new numbers. And then just taking what it says. So height is 2, radius is 4, and 50.796. Boom, we already did half of this week's homework in the past few minutes. Have a great day, y'all, and I will see you on Monday.